The next antenna property I'd like to investigate is called antenna efficiency. And efficiency is really a measure of how much power actually gets output by the antenna as compared to the input power delivered to the antenna by the signal source. So if we were to look at this plot here, we see that there's some sort of power input into the transmission line that the antenna is connected to, and only some of that power is going to get radiated. And so we define the total total efficiency of the system is that radiated power divided by whatever that input power was from the input terminals of the T-line. And so a high efficiency antenna has most of the power that's present at the antenna's input, with these input terminals. Most of that power is going to get radiated away. A low efficiency antenna has most of the power absorbed as loss within the antenna or reflected away due to some sort of impedance mismatch between the antenna and the transmission line. So those are kind of the two major sources of loss, is either reflection loss or dissipation loss here. So the overall efficiency of the antenna, this E0, it really consists of three factors: ER, EC, and ED. And here, again, E0 is just total antenna efficiency, and it consists of three parts: reflection efficiency, conduction efficiency, and dielectric efficiency. ER is the reflection efficiency, and it takes into account losses due to the impedance boundary between the antenna and the T-line, and that is ER is equal to 1 minus the value of the reflection coefficient that's formed between the antenna and the transmission line. We square that, right? It's pretty easy to see that we can create, if we're just diligent engineers, we can eliminate this reflection efficiency completely just by matching the T-line to the antenna right there. EC, on the other hand, is called conduction efficiency. It accounts for the losses in the conductor in the antenna. How we control that is just use good materials in the design of the antenna. And then ED is the dielectric efficiency, and it accounts for losses in the dielectric. And again, we can just control that by building the antenna out of high quality dielectric materials. Usually we will find that EC and ED are almost impossible to compute, and usually they are determined experimentally, and even when we are able to measure them, it's almost impossible to calculate which portion of the losses are due to the conduction efficiency and which portion of the losses are instead due to dielectric efficiency. So in most practical applications, we don't define EC and ED, we just combine them into an overall efficiency. We call this antenna radiation efficiency. And it is equal to EC times ED mathematically, but really this is usually a quantity that is measured for an antenna. It's antenna radiation efficiency.